Okay, section 4.8 talking about coin and interest problems. And the quicker you are able to master these, the quicker you will just not have that painful process every time you have to do a word problem. The only way to solve these is to set up a table. And if we look at example number 1, it says that Chris has 17 coins, and they are all dimes and quarters. So I have dimes and I have quarters. Well, we know that we have a quantity of these, and we know we have a value of these, and that's the individual value. And then what we have is a total value. If I have 5 dimes in my pocket, I know I have 50 cents. So I know that the value of my dimes is 10 cents. The value of my quarters is 25. Now, in order to set up a table like this, we're going to have subtotals. So let's look at the problem. It says Chris has, okay, now this would be my total, has 17 coins total. So we have 17 total. We don't know what the breakdown of the two is yet. And they are all dimes and quarters. If he has a total of $2.45 in his pocket, how many of each of these coins does he have? Well, okay, so I need a variable, and I can only have one variable or I'm not going to be able to solve the equation. So we're going to make dimes be my variable, and we'll just put D for dimes. Well, what does that make for my quarters? Well, if I have the unknown number of dimes be D, that means my quarters have to be everything else. And since my total is 17, I'm going to subtract the number of dimes I have from it, and that'll give me how many quarters I have. So it's going to be 17 minus D. Now this should equal. Okay, so if I have D plus 17 minus D equals 17, and you'll find out that that does equal because the D's will cancel out and you're left with 17 equals 17. So I don't know if that helps at all, but just knowing that it is supposed to equal. Okay, and so then I carry this across. Well, what's my total? Is each dime is worth 10 cents, so it's 10 times D. Each quarter is worth 25, and I know that I have 17 minus D. Okay, so what's my total over here? I have 10 times D plus 0.25 times 17 minus D equals $2.45. Got some decimals in here. And let me see, I'm not sure if the book, yeah, the book does it as well. I don't like dealing with the decimals. It just makes it a little bit cumbersome. So I like to get rid of the decimals, and we know that you can do that by multiplying it by a whole number, 100 or 10 or 1,000, whatever it takes to get rid of the decimals. And since it's two places, I have to multiply it by 100. So I multiply everything by 100. As long as I do the left side and the right side, I can multiply it by whatever I want because the equation is still equal. So 100 times 0.10 gives me 10D. Now notice here that if I multiply 100 times 0.25, I got 25. It doesn't change what's inside the parentheses because this is all one equation. This is all one term. I don't know if term is a good use to word, but whatever I do to the outside is automatically going to do everything on the inside. So that becomes 25, and this becomes 245. Now I'm dealing with numbers that are easier to manage and to work with. All right, let's continue. And I can see already that the book has done it a little bit differently. Did I ring something wrong? Okay, well, we're still good because there's two ways to do it, and I just did it the opposite way of what the book did, but we should still come up with the same answer. It's just that I might have to have a calculator out to do some of the math here because I have 25 times 17. Unless you know that off the top of your head, that comes out to 425. So if I have 10D plus 425 minus 25D equals 245. All right, and I simplify it. 10D minus 25D is a negative 15D, and I subtract 425 from each side, so 245 minus 425 is a negative 180, and I divide both sides by a negative 15, and D equals 180 divided by 15 is 12. So this says I have 12 dimes. Well, if I have 12 dimes, that means I have, and I go back up here, and I say D equals 12. Q equals, or quarters equals 5. 17 minus 12 is 5. Okay, I still have 17 coins. Now dimes are worth 10 cents a piece, so that is $1.20. And obviously 5 quarters is $1.25. And it should add up to 245, and it does, so I can circle my answer. Now in the book they did it just the opposite, and it really doesn't matter. I could establish my quarters as my default variable, and so really you're going to see at least 2 different ways to solve every problem. So you might not yours might not be the same way that I did it, but their solutions still come out logical and correct. Okay, well, let's look at another example real quickly. It says there's another coin one in there, but I want to jump down and I want to do the investing the money thing, because people have that difficulty as well. And basically, you know that if my principal, the amount that I am borrowing or the amount I'm receiving, times my rate, and it's my interest rate in decimal format, times my time, which is typically a year, but we do have to watch, equals my interest. Now my time can be a year, could be a half a year, could be a year and a half. And so you have to be careful to put that in the right formula, making sure that the rate and the time are equivalent. For example, if I told you that my annual interest rate is 12%, okay, this is not part of the problem, it's just an addition, and this is 12% per year, okay, and they say it's going to be 6 months loan. Well, the month and the year do not coincide, so I have to put my time in a format that it's going to be in years. So that means I'm going to have to do a half a year or 0.5. Okay, so my year or my term and my rate has to coincide so that it's equivalent. And you will have to watch that on some of the more difficult problems that they probably won't do that right away, but it'll be later in the book you'll have to deal with that. Okay, it says that Chris invests the same amount of money in each of 2 accounts. So we have account 1 and account 2, and it says that we're investing the same amount. And he gets $36 worth of interest at the end of 1 year. So he made $36, and he held them each for 1 year. Okay, so we know that so far. If the account earns 5% in decimal format, 0.05, and the other one is in 0.07, okay, and I could have switched those 2 around, doesn't matter. How much was the total amount invested? Okay, so we don't know how much was invested. Well, if it says that they are equal, so that means we could just say, well, X. Because these 2 are equal, I can use the same variable, and then I just multiply it across 0.05x and 0.07x. And then if I add those 2 together, that has to equal $36, and I can find out how much my investment is. 0.05 plus 0.07 is 0.12 in my math, equals 36. I'm going to drop the .00 for a second. 36 divided by 0.12, and it comes out to be X equals $300. Okay, so I invested $300 into each of those accounts. So again, to set up these equations, you're going to have to create a table and get the variables in the right spot and make sure that you can work the problem. These are going to be difficult, they're going to be time consuming, and you might have to keep referring back to the examples in the book so that you can set them up properly.